that where I have ideal gases, we can write any of these kind of sets of formulas for mixture of gases. And so the following would also be true. We can define something X, let's say for gas A, and we call this a mole fraction. Let's move this up. Mole fraction. Well, the following would be true for the mole fraction. The mole fraction is defined as the fraction of the moles of interest divided by the total moles. It's kind of like the percent by mass, except you don't multiply by 100. So it's the mass of it, the moles of interest, moles of A, divided by the total moles. And that's called the fraction of it. What? Did you bother and brawl? You bother brawl. It's cool. It's also happens to be equal to, and I won't derive this, but the volume fraction will equal the mole fraction, and will also equal the pressure fraction. Doesn't this stuff happen in your other classes? And if I look at just these two, traditionally NA over N total equals PA over P total. This right here is what we traditionally call Dalton's law. So all the rest of the kind of additions and setup formulas might fit under what we call Dalton's law, but traditionally, if you see it in a book, this is what's specifically called the formula for Dalton's law. And you can rewrite this a little bit in different ways depending on what you want, because this will equal the mole fraction. You could write PA by cross multiplying equals to XA times P total. This is another way to write it. That's Dalton's law. And we can use this in calculations. So what I'd like to start with you is to show you a solving method and how that works. And you'll see this again next time, but let's just go over it a little bit. Let me get an overhead to put over this. Dude. Okay. Dalton's law solving method. So before we do, what is that? Get rid of him. Get rid of him.
No,
Get rid of him.
I have my rights. Okay, go out that way.
Okay. So, how do you solve the Dalton's law problem before we do an example? There's other methods that exist. They work well, totally fine. This is my typical method of solving. Okay, and sometimes you can kind of sort of skip steps. This depends how the problem's written. But what we're going to do, first you have some given units, usually mass, or you could be given like the pressure, the volume, and the temperature, stuff like that. It looks like the ideal gas law problem. And what I usually do is convert to moles. And I convert to moles using the ideal gas law. Oops, that N, this N shouldn't be there. Pig probably wrote it. There we go. Okay, you convert to moles. After you convert to moles, it's helpful to find the total moles. Pig's doing over there. Okay, so you find the total moles by adding up all the moles. Once you have the moles, then it's helpful to get the mole fractions. So you've got your given units, you go to moles. Usually you use the ideal gas law, but you don't always have to. It kind of depends what information they give you. And then once you have the moles, you want to add those up so you have now the total moles. Once you have the total moles and total, you can find XA, which is the mole fraction. And A just represents the mole fraction. Okay, dude, that's not cool. Once you have the mole fraction, you can find the total pressure. How do you get the total pressure? Again, you can use the ideal gas law because now you know N total and usually V total will be given. So you're just using the ideal gas law. Now sometimes the total pressure is just given. It's not always atmospheric pressure, it depends on the problem. But sometimes it can be given. Finally, and again, it depends what they ask you for, but you can go on, find the partial pressures. And here, totally the traditional Dalton's law. You know the mole fraction, and you know P total. You can find the pressure of a particular gas, say gas A. Okay? And this solving method is my typical method for solving your standard Dalton's law sort of problems. Let me see if I can fit it all on here. There you go. Okay, so there's the flow that you would go through to solve something. Is there a question somewhere? Yeah. Oh yeah, the pretty girl. Yeah. What would be a mole fraction? It's more, he wants an example of it, it's more a mathematical entity. It's going to be a number between 0 and 1, thus fraction. And it basically symbolizes how much of a particular gas you have. So say a mole fraction of 0.95, something close to 1 would mean you have a lot of that gas. A mole fraction of 0.1 would be a very little amount of that gas. So going between 0 and 1.
What is it a fraction of?
It's a fraction of the moles existing in the mixture. So you ask what it is a fraction of. It's a fraction of the total moles in the mixture. So you have multiple gases in the mixture. Let's say you zero on a gas B. Hey, hi. And then once you have gas B, the moles, and you have the total moles, you can find out the fraction of the moles, basically telling you how much you have in there.
So 0.95 would be like 95% of the...
Basically, 0.95 would be 95% of the total. Exactly, yeah. And it's a helpful variable to find so that you can get what is the partial pressure, which is the equivalent of kind of the partial moles. Okay.
Wait, what?
Okay, I am going to call our class to an end. We are done for the We're done for the day. I hope you enjoyed our Halloween show. If you dressed up, Mo, can you come up here? If you dressed up, Mo has some extra credit sign-up sheets. You can't look stupid, okay? You have to look like you're really dressed up.